So this is lesson 3.3, slope-intercept form of a line. Our objective, I will be able to write linear equations using slope-intercept form and graph linear equations in slope-intercept form. How do I use slope-intercept form of a line to write and graph linear equations will be our central question. Here's some key terms you need to be familiar with. One is the linear parent function. You notice it's y equals x. The y-intercept. Y-intercept from this point on will indicate using a lowercase letter b. And the slope-intercept form of a line, which is written in the equation y equals mx plus b. Before we get started, I want you to remember two things. That the y-intercept is letter b, and since it's letter b, it can still be written as the point 0, b, even though we know b is the same as y. Also, know the reason why it's 0b. The reason it's 0b is because everywhere on the y-axis, x is equal to 0. Here's some steps that you can use when writing an equation in slope-intercept form when you're given a table, a graph, or points on a line. You want to first find m, the slope of the line, find the y-intercept b for the line, and then substitute your values for m and b into your equation, y equals mx plus b. Please take note, when you get to step 3, substitution, y and x do not change, because you're writing an equation. Y and x do not change. Keep that in mind. So here's our first example of writing an equation using slope-intercept form from a table. So when given a table, we know we need to write the equations. If the directions tell us to write the equation in slope-intercept form, we know at the end of the day we need something to look like the equation y equals mx plus b. Unfortunately, I need to know two things that I don't have. I need to know my slope and I need to know my y-intercept. So in order to find slope, we're going to use what we did in a couple of lessons ago. We're going to use the slope formula. The slope formula, if you remember, was equal to the change in y, y2 minus y1, divided by x2 minus x1. Get a minus sign there. Once I have my slope formula, I have to choose 2 points from the data set given to substitute. What I like to do is go ahead and label each point. So my first point that I'm looking at, I'm going to use the point -2, positive 7 as my x1 and my y1. And I'm also going to choose the point 2, -5 as my x2 and my y2. It really doesn't matter which 2 points you choose. You just need to choose 2 points. Think about our last lesson, couple lessons ago when we looked at the formula for slope. As I showed you in class, when using slope, I'm just going to substitute. And when I do substitute those values for y2, y1, x2, and x1, I'm going to use parentheses. Get in the habit of using parentheses whenever you substitute or change the value of a variable. So for my y2, I go down. Y2 is just -5, so I substitute -5. Y1 is positive 7. X2 is going to be 2, and x1 is -2. The reason I use parentheses is because when I use the calculator, I'm going to type it in just like it is. And I'm going to evaluate now. -5 and -7 give me -12. 2 minus 2 gives me positive 4, so my slope is actually -3. So half my equation is solved. I got m equal to -3, so I put a check mark. I found my slope. Next thing I need to do is find b. In order to find b, though, we're going to use what the definition of y-intercept is. The definition for y-intercept is simple. The definition for y-intercept is going to be the point where it touches the y-axis. But look at the table. We don't have a graph. We don't have a y-axis. But what we do have is an x value equal to 0. Keep in mind, when looking for the y-intercept, we're looking for x equals 0. Therefore, my y-intercept is going to be right there, wherever the point is equal to 0. So for B, I have it equal to 1. So I simply can write B equals 1. Put a check mark. Now that I have M and I have B, remember what I gave you, the hint, y and x will not change. I can write my equation in slope-intercept form. Y equals negative 3x plus 1. Notice y and x didn't change, and I've just done what the question asked me to do, and it's to write an equation using slope-intercept form from the table. So what happens when I don't have a table and they give me a graph? Well, when they give you a graph, the process is still the same. You still want to find the equation in slope-intercept form because that's what it asks us to do. But this time, we're starting from a graph and not a table. You still have to have M and B, so I'm going to put my equation right here. Anytime I see slope-intercept form of a line, I'm going to automatically write the equation. Y equals mx plus b. Right now, I know I need to find M and I have to find B. Based on the information that's given, let's see if I can find M first. Remember from class, we talked about M slope is equal to rise over run. If slope is equal to rise over run, I simply have to go through my graph, and I'm going to count from one point to the next point to see if I can find my slope. So I'm going to choose 2 points to count from. I'm going to choose the point negative 0, negative 5, and I'm going to choose the point 5, 0. And simply going to do exactly what we did in class. My rise is going to be 1, 2, 3, 4, 5. Since I went up 5, I'm going to write that as positive 5 for my rise. And now let's change the color and get the run going. Now my run, on the other hand, is going to be 1, 2, 3, 4, 5 as well. So when I write my slope formula out, it's going to be rise, which is 5, over the run, which was also 5, and that simplifies to, you got it, 5 divided by 5, positive 1. So now I know my slope. That's good and dandy. But there's something else we'll have to find. We have to also find the place where it touches the y-axis. Using the table is pretty easy. So when I look at this, do we readily see where it touches the y-axis? Absolutely. It touches, the graph touches the y-axis there at negative 5. So B is real easy to find. I can simply write that B equals negative 5. So I put a check mark because I have B. I have M and I have B. I can write my equation. Y equals positive 1x plus 5. And again, we don't have to write that 1x, so you may as well see it without that 1, but I'll leave it in here for training purposes. And now we have our equation written in slope-intercept form of a line. Our third example says writing an equation of a line that passes through 2 points using slope-intercept form. So as I look at this one looks a little bit different because I don't have the y-intercept readily, but I do have 2 points. Since I have 2 points, I can use my slope formula just as we did before. So let's go ahead and label our points. Our points are going to be labeled. The first point you come to, we read left to right, that's going to be x1 and y1. My second point, since I only have 2 points, naturally it's going to be x2 and y2. After applying the slope formula, you should get something like -5 over +5, and that's going to reduce to -1. So we have our m, just as we did before. If you want to do that little check mark, check, you could check m off. Now let's find the y-intercept. This one's going to be a little trickier though because we don't have it ready. But what I do have is y equals -1x plus b. Notice I didn't have a number for b, so you can't change it, but I did have m. In order to figure out what b is, I get to choose any one of the points to substitute. Now notice, I'm going to use the equation to help find b. We said before x and y don't change. Remember, I'm not putting x and y in to solve the equation. I'm putting x and y in so that I can find the value of b. So when I substitute, I'm choosing the first point. So that means whenever y is 4, the slope still has to be -1, but my x value has to be -2 whenever y is equal to 4. So now I know, because I substituted, now I know now with that information I can find what b is. Solve for b, just like we've done before solving equations. You'll get that b is equal to +2. Now that you have m and you have b, you can write your equation now. Pay attention to the directions. My equation, y and x won't change, but my slope was -1x and my y-intercept was +2. Once you have that equation, you are done. So those are 3 quick examples we're looking at solving equations writing equations, from a table, a graph, and just any random 2 points. But what happens if I want to go the other way? What if they give me an equation and tell me the graph? Well, the process will be the same. You want to identify m, the slope for the line y equals mx plus b. Sometimes you may have to solve for y first. The next step is find the y-intercept. Begin your graph by plotting the y-intercept first. Use your slope, rise over run to find a minimum of 3 points. And the last step will always be to draw the line that goes through those points. In this case, it says use slope and y-intercepts to graph y equals -3x plus 7. I want to identify slope and identify y-intercept. So if you look at this, sorry about that. When I look at this, I can go ahead and identify slope is always be the coefficient of the term with the x, and y-intercept will always be the constant whenever y is isolated. So if there's a great question to ask yourself, it'll be, is y isolated? In this case, yes it is, so the slope is easy. M equals -3 and b equals 7. But I don't want to leave it just as a 7. Just a reminder, it's a point because we're looking at a graph. Anytime you look at a graph, remember the y-intercept is a location. So you're going to have b equals 7, but written as a point, it's going to be 0, 7. So now the steps told us to go ahead and plot the point 0, 7 first. So on my graph, I'm going to go ahead and plot +7. And then I'm going to apply my slope formula to find 2 other points. So I go down 3 over 1, down 3 over 1. Once I have 3 other points, the next step is history. It says to draw the graph that goes through the line. Draw the line that goes through those 3 points. So what I have is this graph right here. And now that we have a graph that represents this. Little housekeeping. Whenever you graph a line, make sure you put arrows on both ends of the graph. So same steps for this one. I'm going to identify, is y by itself? Absolutely. Since y is by itself, I'm going to go ahead and identify my slope, identify my y-intercept. Once I have slope and y-intercept, just for clarification, we'll write it down. M equals 1/2. That's the number in front of the x term. And b, be careful. the sign in front of the number stays with the number. It's like a name tag. So we're going to say b equals -2 and write it as its location because we're talking about a graph now. 0, -2. Same as we did before, we're going to plot the y-intercept first. There's the y-intercept at -2, and we're going to apply our slope formula to find a minimum of 2 other points. So 1/2 means rise 1, run 2, up 1, 1, 2. Up 1, 1, 2. I'll do one more because I'm practicing using this pen. It's not really working for me. And let's draw the line that goes through those points. And there's the graph. And again, we want to make sure that we put arrows on both ends to indicate that the line goes on forever. Bear with me, 2 more examples. So for this example, it says graphing a line from y equals mx plus b. First question we ask ourselves every time is y by itself. If you notice in this equation, y is not by itself, so what do you think we have to do? Yeah, get it by itself. So we're going to take the 2x plus y equals 1, and we're simply going to solve for y. Not going to show that step. This is something that you should be able to do right now. Subtract 2x from both sides. We get y equals 2x plus 1. Once you have y by itself, next step would be identify your slope. Our slope here, the coefficient of the x term, which is -2. My y-intercept is going to be equal to 1, but remember, anytime it says graph, make sure you write its location. Its location is 0, 1. Now, same song, different verse. I'm going to plot the y-intercept first. The way I like to remember it is like this. Y-intercept is b, so when I graph, b is where I begin. So I'll show you what you should be doing at home. In this column over here, I will write b, begin here, and that simply means whenever you get to graph, you're going to begin here. Begin with that y-intercept. That's your starting point. So our starting point here, our beginning point is 0, 1. So I'm going to go to 0, up 1, put a point. Yeah, that didn't work. Let's try again. There we go. And apply the slope. The slope is -2. And if some of you getting confused, I remind you, -2 can be written as -2 over 1. So that's how I know how to move. So I'm going to go down 2, 1, 2, to the right 1, because it was negative. Try that again. Down 2 to the right 1. Down 2 to the right 1. Once you have a minimum of 3 points, and I'll give you one more, you draw the line. Please use a straight edge when drawing your lines. It's important. And draw the line that goes through those points. And put an arrow on both ends. The arrow is crucial. So, went a little bit too far. So the last one we'll look at, hold on. The last one we'll look at is actually called a parent function. The parent function is the one that is I call it the granddaddy of all linear functions, because every other line comes from this equation. And the parent function equation is real simple. Ready for this? Y equals x. That is the parent function, the same one you saw in the vocabulary. So for y equals x, our parent function, the key characteristics that you will see here is that its graph is going to be a line. We'll see on the next slide. But x and y intercepts are both equal to 0. X and y intercepts are both equal to 0. It has a slope of 1. And what do you mean it has a slope of 1, Mr. Arsenault? I don't see a number there. Remember, the number in front of the x is a slope, and there's an invisible 1 there. And lastly, all linear functions, all other linear functions come from this parent function, hence the word parent. So let's look exactly what this graph would look like. So if you look at this at first glance, you're like, how in the world am I going to use slope and y-intercept to graph y equals x? Well, the steps are the same. Identify slope. Slope is going to be the number in front. just like we did on the last slide, y equals x, but we know that there's a 1 in front. So I can write for my slope m equals positive 1. What about b though? What about b? Do we see a b? Let me help you out. If I put plus 0 here, does that change the problem? Absolutely not. Whenever you don't see a number or a constant, you're going to assume that that y-intercept is equal to 0. And again, since we're graphing, we're going to write its location, 0, 0. So, just as before, B began here. We're going to start by plotting that point, 0, 0, and get the graph drawn. You might know another name for the origin, if I can get the point down. So there's 0, 0. My slope says up 1 over 1. Oh, this is going to be interesting. Up 1 over 1. Up 1 over 1. Up 1 over 1. You get the idea. Once you go up 1 over 1, follow your slope. Have a minimum of 3 points. Now you can graph it. Just draw the line that goes through all of those points using a straight edge. And there's your graph. Lastly, put arrows on both sides. So, this kind of concludes graphing, it concludes slope-intercept form of a line, writing equations in slope-intercept form, and also graphing. Be ready with questions when we come to class, because we're going to be doing a lot of these and different variations of this equation. Hope you have a good evening. We'll see you in class.